as we move on to reading tables, I'm actually going to move backwards a little bit and look at the NA, how different ways to handle NA, and then we'll move onwards. So as the section for reading and writing tables finished up, the book Gries suggests some further explanation for NA, is.na, nan. So let's see, I'll put down here just some of those. So NA, and you can see here that it turns into a different color, and that's because it's a special character of missing data and it's not the character string of NA. So that's worth noting. You can, well, I'll save that one. There's not a numerical NA, which is another special character if you're working with more with numbers, and it's essentially 0 divided by 0. So what I think is most useful for now is going to come back to this one where I had read in a file that was missing one piece of data, and it reads in as, it treats that missing data as NA. So let me do that. I will input it, and I put that one in book 3, X3, and here's the missing data right here. So some of the useful ways of starting out looking at that missing data is, first off, looking at there is any missing data. Suppose it were a large data set and you couldn't visually look through and see like we can see here, is you could do a summary. And this will give you quite a lot of information about minimum, median, medians, means, and so on. But particularly right here, looking at, okay, there is some missing data. And then you would say, okay, how are you going to handle that? And how do you find out where it is? So the first thing that I'm going to suggest is an alternative way to know that same information regarding is there missing data, and that's simply na.fail. And it will return that there's missing values, so it'll fail if it should fail. If we want to see that with X, and let's just run X so that I can confirm, yes, there is no missing data there, and notice it returns the, I guess I could have done that already, that it returns the frame rather than failing as it did when there was missing data. So it just plain tells you, yes, there's missing data in there. One thing that I did just to kind of confirm for myself what this NA was to test it out as just a character string versus NA. And visually you can see it in RStudio, but to see how it's handled differently, and also to see one more test is the function is.na. So you're checking it, is it the NA or missing character? So if we started off with C, which we know is a character string, oh, I should run these first. So run it, and it will return false because it's not the missing data, NA. If we do it with B, it returns true because what we gave it is missing, it's the missing data variable, so to speak. So going back to our data frame with the missing data, if we wanted to be able to take out the observations with the missing data, there's many different ways to do this from what I'm seeing. One is na.omit, and it should return everything that takes out the lines with NA. So it's like all our data rows without NA. There's ways to do that with, if you have a larger data set, to take out just certain percentages of missing data, but I'm not going to go into that right now. Another one is complete cases, and this one returns the locations of the rows that are complete, have no missing data. So it shows it across, but it matches up with the rows. So if you wanted to see those rows of complete data, then we can use that as location. Oh, because it's a data frame, when you put it in the brackets, and this is actually what we're doing just after this, is that's the row location. It needs a comma, and if you give it the column, it'll just give you that column, or if you don't put anything further, it'll give you everything. So there we go. So this gave us all but that one with missing. So essentially, the na.omit and these, the complete cases here, did the same thing, only this one lets you be more specific if you want to be more specific. So let's leave the NA section with that and move on to with what we're doing next. We have the next step, we're on page 48 now, bottom of the page. We've already read in the table into X. Let me confirm that that's what's there. So I'm not going to, oh no, have I read in the same one? Oh, I already read this in, but let me, so this isn't the same X that I was working with before. This is one from one of the data files from Gries. So we'll choose the file. This lets us find it. The header equals true. It's separated by tabs. And it looks like there's an error in my version of the book. There's a semicolon here. And there's no reason that I see, so I'm going to omit it. And if it runs anyway, then I think that I'm right. Could not choose, oh, files. There we go. Okay, so this should be in input frames, or input files, data frame, the text document. So it reads it in. We'll double check that it is the same one. Okay, so following along, we're going to look at the structure of it. Should not be anything new. Why is it running at 2? Let's try this again. Okay. So we've got 5 observations, 4 variables. A couple of them have factors, open, closed. So what we're looking at here is accessing just part of the data frame using the $sign. So the first one is if we use X and the $sign, and then the name of the column that returns the full column. So token frequency, it returns the full column, and we can see it right there as well. Try it with one more. Should really be a factor. So it returns it like a factor, tells us the level. This next one is pretty interesting because it lets us avoid so much typing. And using the $sign, which is attach, and then the name of our data frame. So we attach it, and then this should let us access, I don't know if it's masked. Oh, I already attached it once, so let me detach. And then okay, I'm not sure why it's doing that, but let's see if it still works. So what this should do is it's attaching the values kind of locally so that we don't have to say $$ every time we want to access a column. So if you had multiple data frames, you would probably have trouble if they had the same values and you were trying to attach them all. You would want to do them one at a time. So let's see what it did. So if we go class, then we see everything that's in class, and we didn't have to go. We can still go $, and it gives us the, wait a minute. So this gave us factors, and this didn't. That's odd to me. Now what I'm going to do is remove X. Okay. So that was the problem, is that I had the local values and there was a conflict between the local and the X data frame. I'm not sure why the detach didn't do what I thought it was going to do, but let me see if I remove class. All right. I'm just going to come up here and remove everything. If we read this in, input files, I'm going to attach it again. Following object is masked. Okay. What if I detach it? Run class. For some reason, it doesn't seem to be detaching, but it's certainly attached. Let's go ahead and keep moving forward. Token frequency. Okay. So the parentheses are going to let it output directly to the console. Token frequency should be accessible for the column, and the 4 here should tell us that it's the 4th row down, so that we can hypothesize at what we're going to be finding out. The token. The token frequency should return the 458. There we go. So one more thing is, one way that we can access the same information is, this is not related to be attached or not, but just using X and the brackets for the locations. Now we have 2 locations, and the first one is going to be your row. So if we want to access the same thing, it'd be, wait a minute, row is going to be the 4th one. So it's 1, 2, 3, 4 of our data, not counting the header, and the second one over. And we'll return the same one. If we accidentally reversed it, you can see that we'll get one of the open values. So let's wrap up there, and that should be enough for now.